3 of the exam review worksheet, and it comes from chapter 3, where you learn different techniques for analyzing circuits, and this problem uses nodal analysis. So the first thing we have to do is identify our nodes. So let's make this ground, and then see if you can identify what the other nodes are. So we have one here, and we have one here. And that's it. So we just have the two nodes, and that means that we will be able to have a system of equations that we can solve without using a computer. So, fair exam question. Now, nodal analysis relies on KCL, and it relies on the fact that the sum of all of the circuits at a node has to be 0. And so what we do when we do nodal analysis is we assume all currents start at the node. And so they're all coming out of the node. And so if you add them all together, they have to equal 0. And you get the current by taking the voltage at the nodal source, at the node, take the voltage at the node minus the voltage on the other side of the resistor, and divide by the value of the resistance, and that will equal the current. So you're always starting with the node minus the other voltage over the resistance. So our first set of equations, let's do this node right here. So we're doing this current, and this current. So starting with this one, and that voltage is Vx. So Vx minus, now let's see what the voltage is on the other side of this resistor. So this is ground, and this is a 1 volt voltage source, so this will be 1 volt right here. So Vx minus 1 over 2K. So that's our first current. Our second current, let's do this one. That'll be Vx minus 0, so that's just Vx over 4K. And our third one, it's going to be Vx, and if you look, it's also going to ground. So, oh no, it's not going to ground. No, of course not, because we have another voltage right here. We've got VL. Yeah. Yeah, there's the resistor right there. So we've got Vx minus VL over 3K. And those have to sum to be 0. Now we'll do our second node, and we have that we'll do, so we've got this current, and this current. And let's start with the top one. Remember, you always start with the node that you're analyzing. So it'll be VL minus Vx over 3K. Now we'll do the one going down, plus VL minus 0 over 2K, plus, and then the last one, VL minus, and this is a dependent voltage source, but it's in terms of Vx, so we can just use that variable. That's one of our variables. So VL minus 3Vx over 1K equals 0. Okay, so now let's simplify these equations a little bit. Get rid of the fractions. So look at the common denominator. The common denominator would be 12K. So the K is going to cancel from everything. And from this first term, the 12 and the 2 will cancel and we'll get a 6. So we'll have 6 Vx minus 1. From the second term, we'll get 3 Vx. And for the third term, the 3 will cancel with the 12 and we'll get a 4 Vx minus Vl equals 0, or 6Vx minus 6 plus 3Vx plus 4Vx minus 4Vl equals 0. And then we have 6Vx plus 3Vx is 9Vx plus 4Vx is 13Vx. And we have minus 4Vl. And take the number to the other side, equals 6. Okay, so now let's work on our second equation. And get our common denominator here will be 6k. So the k's, all the k's will cancel. And for this first term, I'll have 2 times VL minus VX. The 3 cancels with the 6 and gave me the 2. Here the 2 cancels with the 6 to give me a 3, so plus 3VL. And now this is a 1, so that'll just be plus 6VL minus 3VX. And that equals 0. So we have 2VL minus 2VX plus 3VL plus 6VL minus 18VX equals 0. So we have a minus 2VX and a minus 18VX for a minus 20VX. And then we have a 2VL plus a 3VL is a 5VL plus a 6VL is an 11VL. And that equals 0. So that's our second equation. So we have a pair of simultaneous equations to solve. We have this one, and then we have 13Vx minus 4VL equals 6. And so we want to multiply them both by something so that one of the variables will cancel. And so let's multiply the top one by 4. And the bottom one by 11. So then we'll have plus 44 here and minus 44 here, and so those will cancel out. And so our top equation, we multiply through by 4, gives us minus 80Vx plus 44VL equals 0. And the bottom equation, 11 times 13 is 143Vx minus 44VL equals 66. So add these two equations together. These cancel. And 143 minus 80 is 63. So 63Vx equals 66, or Vx equals 66 over 63, which equals 1.0476. So the problem asked us to find VL, and so of course I managed to find the other one first, so now I have to plug back in to get the correct one, VL. So I can choose either of these two equations. I'll just choose the top one and I'll plug in for Vx and then we'll find VL. So we'll have minus 20 times 1.0476 plus 11VL equals 0, or minus 20.9523, bring the 11VL to the other side, equals minus 11VL. Divide both sides by negative 11, and you get that VL equals 1.0476. 9048. And that's the answer we were looking for.